And what about you? Okay, here we go with the breakout boxes again. This is a follow-up video. A few comments, questions and concerns in the wee video I posted previously to this one. There'll be a link in the description to the previous video and vice versa. And here we go. Okay, a few questions on this video here. I'm going to read a few of them out. Not labour this too long here. The Gibby 3340 looks like pins 4 and 5 are longer as a safety measure. First and last to break. And he asks, are 4 and 5 jumped together internally? On my cheap rig, 4 and 5 are common. I'm not a fan of this configuration, and vehicle would see a ground adrift and it would be unseen by the breakout box. Okay, I replied, well, certainly on that one. They're definitely separate, and I'll test this one to see if that's the same. Let me see. Sam Stone then, you can change the resistors on section 14 for CAN bus signal to make them flash on the eBay one. And he's done it, and he says there's a YouTube video for that. I couldn't find that video, but I am aware of that, and I'll show you later in the video how to do that if you want to do that, and that's modify this. But it's not the end of the story by any means. There's other issues with that thing, and I'll show you that as well. So you can do that mod if you want, but it doesn't actually solve all the problems. Let me see. That's the main ones there. Oh yes, Weldon Junkie, aka Jay, from the East Coast of the US. A guy with good Irish breeding in him. Nice job, Dave. He is a can-do breakout box. He is a can-do scanner as well. He seems to like that can-do stuff. And he sent a wee link, an Amazon link for that one. He says his has a built-in breaker. And he was going to get the Power Pro one you showed, but yeah, I wanted my scope to use with it, and the can-do accepts shielded banana plugs like the OTC. Okay, I didn't show you the probes that this thing uses, so I'm going to do that now. Okay, yes, this takes shielded probes, and this one here takes, it's very small wee holes in it there. So it takes these things here. Get you back into there again. So it takes it's applied to these two wee boys here, and they poke in there like that, and they stick in. And that accepts the shielded probe then. So there you go. But these here have another wee feature. There's a lot of outer writing in this, and I'll just in case you didn't know, this does something else. So you get two of these wee boys, color coded there, and there's writing on it, and lettering on it, and all that malarkey. AB, so AA is mini, AB and BA, ATC, and BB is maxi. What that's referring to is fuses. So mini, maxi, and ATC fuses. So I'll just show you that. There's wee magnets on the side there. So and as you can see, there's offset blocks on it, so when you swap these about to any orientation, it changes the sort of spacing there on them. So we'll get a wee mini fuse, and that is going on that. So if you're doing parasitic drains and you want to, you're looking for a parasitic drain and you're going to cross a fuse, they're looking for a potential difference in the fuse, or a blown fuse. You're looking for a blown fuse, and that is the idea of that. So that's just a wee byproduct of that. A wee boy there. So they plug into there, and you just connect your lead to it. So that's the way you use that. Oh, get it into there. Don't stick it in the LED. Okay. So there was a bit of chat about these CAN signals in my example video. I was plugged into a Citroen. The main thing of that video was it was actually the PSA, the DLC plug, and the issues that can give you. And on that particular one, the can high and the can low wasn't showing, and that's purely because the threshold wasn't high enough to make these LEDs light. So to make these LEDs light, it needs to be up and around the 4 volts or 4.5 volts. So one's going to be higher than the other one, but they actually do work. Now, I know Joey from V for Vauxhall, a Scottish guy.
Certainly a better one than this. This is just crap. So thanks for watching.
He bought one of these and he didn't like it at all. He completely binned it, I think, right away. He plugged it into a car that he was working on, and there were other communication lights weren't flashing, and he was comparing that to a Pico, and the Pico had 3 or 4 communication lights flashing. A few of these ones here, probably OEM specific ones, and this wasn't flashing at all. It was just those, which is what I was seeing in the Citroen. So you can do that resistor mod to get your cans working, and as I said, I'll show you at the end of the video. You can do it if you want, but there's what I've also found is this voltage reading also isn't accurate either. So yeah, but anyway, the answer, Ian, yes, the pins are separate in both these boxes. I've tested them, and that is true. So whenever we take the back of this off, you can see 16 separate wires in there. So I'm not gonna. Well, I may take it apart. I may take that back off just to show you what you have to do to do this modification. But if you've got plenty of time in your hands and you want to do that, then that's dead on. But I'll show you how to do it if you want. But anyway, I'm going to plug this into my own car here, where the CAN signals are a bit higher. So here we have the 2 bulbs plugged into the car. One's reading 12 point. It's jumped between 12.5 and 12.7. That's a steady 12.6, and we're reading 12.5 there. So that the white one there seems to be reading a wee bit high on the voltage. So yeah. So when we open the car door, it'll wake this thing up. So let me see. Keep an eye on the lights. So once we open the door, that's the CAN. That's the network activated, and the CAN lights are working on the on that one there. Or on both. They're working now on this one. The previous video, these weren't lit up. And if I just pull these leads out and put them into the CAN there, and see it's up in the region of nearly 5 volts there on the CAN low, and the CAN high there, it's about a quarter volt. So that corresponds with this, okay, but if I remember from the other video, the wee Citroen was only reading about 2.5 volts, I think. So yeah, so what's that saying now? 12.2 volts. There's 12.3 there. So another wee feature this has is it has an audible signal to warn you. So if you have your scan tool plugged into that end, and you're doing a bit of diagnostics, and the voltage goes too low, there's a good loud piercing audible signal comes out of this thing. So I'll just show you that. If you're wondering about that CAN signal, that's it on pin 6 there, and that's the maximum there. So it is only reading half a volt there, but it does peak at about 4 volts. So if I go into that's it there. So There's the voltages there. You see it jumping about there. So it's like an RMS value it's reading there. So that is why that maybe looked a bit low. But so 3.8 volts. That, as I say, I think the reset to them was about 2.5, and that's why they weren't flashing. So the ignition on. Well, put some accessories on. That's 11.5 volts. And that noise is coming out of there. And there's no noise coming out of this other one. So just put the microphone to it there. There's no noise coming out of this one at all. I read somewhere there was supposed to be an audible beep on this, but well, there definitely wasn't this. So here's the thing that Joey from V for Vauxhall noticed. There's another couple of communication signals going on there with the ignition on, and they aren't lighting up at all here at all. So there's still that wee bit of voltage discrepancy there. Just see what the voltage is in the voltmeter. .4 volts, 11.45, 4 to 5. Oh, that's actually right there for a change. So it seems to jump about this voltage here. That one there seems to be a bit more accurate. Although it's making a liar out of me there. So I noticed this voltage didn't seem to correspond sometimes. This one seems to be a wee bit more accurate. But there's another couple of signals going on there. So there we go. The CAN lines do work on this, but it's the threshold. So what people do is you can put resistors in there, but it is a bit of a flaff now because there's a lot of surface mounted resistors in the back of this. So I'll show you. I'll maybe just open this up and show you. Okay, so back on this and back on the bench again in true AVE fashion, we're going to take this thing apart. So I get an oversized screwdriver drill thing, and I'm not going to take this completely apart. I'll show you here in a second why that is. So rubber grommet. So okay, I'll get you in that. So there's all our connections soldered onto there, and there's the 16 wires. So they must breach on in here for the other lead, because that's 8 there and 8 there. So to get this thing apart, you need to desolder all these pins and lift this. That's how this board will lift off, and those connections will lift out then. So they're solidly connected in there. Yeah, so you need to desolder all them, which is a complete pain, which I am not going to do, and I'll show you. It's like is that a wee buzzer there? Supposedly. What is that? No, it's not. It's an inductor. See that? It's like a voltage regulator circuit there. So, okay, I'm going to show you a photograph of the flip side of this board. That's all. I'm going to take this down. So this is a photo of the back of this board, and it's not my photograph. It's from this guy here, Mark Ambudson, and he has changed resistors on the display there as well. But it's that guy's photo. It's not mine. So that's credit to him. And you can see on, let me see if I can zoom in here a wee bit. So there, that resistor there, RQ14. So resistor for 14 there, and he's added that resistor in. I'll try and zoom in that a wee bit better. So that's that resistor there. So these are surface mounted resistors here. The value of the one that's in the board is 1k, and he's upped that to 10k ohms with removing that surface mounted component and putting that in. So that's the one you change for pin 14. And then if we scoot up, pin 6 there, RQ6 then, and he's done the same there. So let me try and zoom in a wee bit on that. So that's RQ6 and RQ14 resistor modification there. So that will bring down the threshold for to make those lights work. The lights do work, but it depends on the voltage on the CAN signal. And there's the other resistors where he's changed with respect to the display just to make it a bit brighter, I think is what he did there. So yeah, so that's the LEDs there. That's the LEDs there. I'll zoom out again so you can see that's in the picture. That's not me doing that. I don't see a wee buzzer at all anywhere, so there mustn't be a buzzer in it for under voltage. So there you go, guys. Maybe that helps you out. You can do that modification there if you want, if you have one of them. But to me, it's just too unreliable for, you know, your test equipment needs to be reliable. Otherwise, it's not much good as a test device. So with voltmeters, I compare voltmeters. I have multiple meters and tools to compare them all for accuracy. So there we go. So that's it, back together again. So I've already bought this, so I'm going to hold on to it. You can still use it for testing purposes, and as you can see, you can link the two of them together and stuff like that if you want. But yeah, that's well, a wee bit more in these breakout boxes. There's a wee bit more to that one. Obviously, you know, it's the old chestnut. You get what you pay for. Yeah, I like things to be accurate, and I like the audible on it, and the voltage on every pin. I like that. So all in the one unit. So that one there, yeah, it's don't rely on the lights at all, or that voltage. It's roughly there. It seems to move up and down. That one there seems to be more accurate. That one there seems to have a bit of a mind of its own. So okay, that's the end of the video. Maybe you got something out of it. Hope you enjoyed it. Thanks very much for watching, as ever, and all the best, and bye bye.